All right, so this is on long division when we have two or more digits. So previous video was talking about a single digit divisor, and now if I'm dividing some number by two or more digits, how is it we take care of that? So I'm first of all going to think about this like we did before, is in a partitive way. And here's what I'm going to think about is let's divide $5.34 to 14 people. So we did some examples where we divided to fewer number of people before. We did some chip models, coin models, and we've got that. Okay, so first of all, I'm going to do, for example, can't divide $5 by itself, or can't say by 14, right? It's not big enough. So we're going to take that, right? And so consider 53 dimes by 14 people. Okay, and so one of the things with this is we might want to think about how many groups can we, or let's see, or how many dimes goes to each person with 14. And we can do that by, so 1 times 14 is 14, 2 times 14 is 28, right? 3 times 14 is 56, right? Sorry, that's 42. 42, my bad, right? 4 times 14, now it's 56. I skip counted though, wrong way. Okay, so we know this, it falls between each of these. So each person get 3, and we have enough, but each person can't get 4. Each person has 3 dimes, and then we have 53 minus 42, 11 dimes left. Okay, so together with that, I'm going to think about this as pennies, right? So 110 pennies, and I'm going to have 4 more pennies. So then how to divide 110 plus 4 pennies to 14 people. And this little table is nice if we just keep going with this. So let's do that. So 5 times 14 is 70. 6 times 14 is that, plus another 14 is 84. Not there yet. And I keep just skip counting by 14. So 98, 8 times 14 is another 14 plus that at 112. So it looks like it's going to be 8. Each person gets 8 pennies. And then there, our 114 minus 112 is 2 left. Okay, so this is the argument that we're making to just do dividing with a greater number. And this is the same argument we use for a single digit divisor, so it's not any different. And again, one of the really nice things about it is if you want to, you can really think about this with coins and everything. This gets a little bit more complicated when you're trying to divide into 14 piles or something, but you know, it's still doable. Okay, so, but this translates directly to our long division. All right, I can't divide my $5 by 14, so the same thing with 14 into 5 there. So we do 14 into 53. And from this little table, we see that 3 is the answer. And 11 is left over. I bring down the 4, and then again, we did 8, right? And we saw this was 112, and I get 2, right? So 38, remainder 2. All right. Okay, so we've got this. All right. So this is kind of the way to really think about how you might think about the way that like long division works, like walking through this with a coin/chip model. And then you can really see, hopefully, right? Hopefully you can see, I didn't point that out so much, 3 dimes, right? And then we got 8 pennies, right? That 11 was the original 11 remainder, and then that 2 is that 2 remainder, etc. So, got that. All right, so what I'm going to do is there's going to be 2 more steps of doing this. So first of all, I'm going to do a different one where we're going to just walk through and build up a table and use the table to do the long division. And then we're going to do some estimation like we were doing previously. Okay, 3026. So we're going to do this, but long division wise, but before I do that, I'm going to build up all the multiples of 17. And again, the easiest way to do this is just some skip counting. So 17 plus itself, 34, plus itself again, 51, plus itself again, 68, 585, 92, 102, 119, 631, and another 17, 353, and if I add another 17 to that, I get 170, so that checks out. So that looks good. Okay. You can just do some sanity checks where you're adding by 7, so you're adding an odd number, so every other number should be even odd. So that looks good too. Okay. So 17 doesn't go into 3, 17 goes into 30, right? It's right between those 2 numbers, so that's just 1, but that's not too difficult. And then subtract 13. Bring down the 2. So I scan down here, at that, between 119 and 136. That's going to be 8. And I get 7. Take the smaller of the 2. And get 119. Right. Yep. And that's 13. And 136, holy cow, exact. Okay. 178. Okay. And 36. Remainder is 0. Okay, so this is another nice thing, again, to start going through things and building up a little table. Right. And then I have 2 more examples, and we're just going to go through and just see, can we do this without the table and get a good sense. So let's look at that. Divided by 31. Okay. So we're going to try to do a lot of this stuff mentally. So this could be challenging, but we could also write down a few little things. So 31 doesn't go into 1 or 17, but does go into 178. Okay. And so now what you're trying to do, right, is we're trying to do 178 divided by 31, right? And I want to try to do this. This is going to be, I want to try to be on the low side of things. So I'm going to do that divided by 30. That's going to go to 150. It's going to be 5. So let's try 5. 5. And I can do 5 times 1 is 5. 5 times 3 is 15. Subtract 3, 2. Okay. So you got to make sure that this gets done right. But this, remember, this is a sanity check. That this has to be, it can be 0, but it can be at most 30, not 31, up to 30. Okay, bring the 4 down. So again, with 31, 234. Okay. So that's going to be 30, and then I think what you're going to have to do is round it down to the nearest multiple of 30, which would be 21. So that should be 7. 7 times 1 is 7. 7 times 3, 21. 14. 1. 17. So I get 57, remainder 17. Okay, so again, this wasn't building the table. That was just doing some stuff, some estimation mentally, and then a bunch of stuff kind of in our head. All right. Now this was kind of nice because I did divide by something close to like a multiple of 10. If it was, say, 34, 36, maybe that would have been more difficult. But obviously there's always harder and easier problems. Okay, let me do one more here. I'm going to do a 3-digit. I'm going to do 195, 195. 894. Div 7, I think 21. 721. Okay. Starting to get a little tricky here, right? But 721 doesn't go into 19, doesn't go into 195. It will go into 1958. Okay, so what you're going to do again is I'm thinking 1958 div 721 is about 700, and then I'm going to do 1400. So that's going to be 2, right? And remember, that's where I start, right? Didn't go into 1, doesn't go into 19, doesn't go into 195, goes all the way to there, so that's 2 there. 2 times 1, 2, 2 times 4. 2 times 2 is 4, and then 2 times 7 is 14. 6, 1, 5. Again, that has to be between 0 and 720, so that looks pretty good. Bring down the 9. And then I'm doing 721 into 5169. I'm thinking 700. Let's try a 7. 7 times 7. So 7 times 700 would be 4,900. Let's see what happens with that. So 7 times 1 is 7. 7 times 2 is 14. So I've got an extra 1 bundled there. 7 times 7 is 49. Plus 1 is 50. And I'm going to erase that. 2, 2, 1. And then bring the 4 down. Okay. This one looks like, yeah, so that 1442 is 2 of them, so this is just going to be one of those. 721, 305. So I get a remainder 503. All right. Good. So obviously these problems get harder as they get a little bit bigger. But sometimes, and again, I set these sort of up to be nice, a relatively close to a multiple of 30, or sorry, a multiple of 10, and this one was close to a multiple of 100, so we could do things relatively okay. All right, so go out and practice some of those.